1.1.1. It's dealing with relations. So if they were to ask you what's a relation, we'll just get right to it. Do you guys ever read the learning objectives your teachers put on the board? No. Not really. Okay, well, let me just tell you this so you guys can like rest assured it's not going to be super hard. We're going to review domain and range, and that's pretty much it for 1.1. Okay, so a relation is a set of objects that are connected in some way. For example, every person has a birthday. So like I could say, Ashley has a birthday in April. That would be an example of a relation. A perfect square has a perfect square root, for example. 7 squared equals 49, so the square root of 49 is 7. So some relations will have a pattern, and sometimes a relation is a random set of x, y points. So it's just kind of understanding a relation can be basically anything, random, or it can have a pattern. So what we're learning at first is how to write a relation in the different ways UVU wants you to write it in. So look at way number 1. Way number 1 is writing a set of ordered pairs. Your relation is a set of ordered pairs. So if they say to you on the test, write your answer as a set of ordered pairs, they just want you to write them as x, y points. So yes, on the test, if you don't study and remember what the word ordered pairs means, you might miss an easy problem. So this is an example right here of a relation that is written as a set of ordered pairs. 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. Today we're really not focusing on if we can determine a pattern, but I'm just asking you for fun to see if we can try to think advancedly. Let's say I gave bonus on the test. What would be the next point? Like, what's the pattern here? And it's okay to be wrong. We don't care. No one cares if you're wrong. So it's 0, 0, 1, 2, 2, 4, 3 goes to 6, 4 goes to 8. What would 5 go to in your guess? It's okay to be wrong. Yeah, 10. So does it appear that we're multiplying the y values by 2? Is that the pattern? Yeah, I can concur with that. If you didn't see that, don't be like, oh, great, I'm in trouble. No, that was not the point. The point was, do you understand that a relation can be written as a set of x, y points? Yes, you do. Okay. Moving on to the word mapping. I would write down in your notes mapping. So mapping, I would just write in my notes, mapping is the circle thing. Go like this. Draw a circle with an arrow. Mapping is a circle thing. It's just writing x, y points in a circle. It's kind of a hoop jump. So notice, like right here, they're just saying in this circle we have whole numbers, and we're going to double them, and then they just point their arrows. So we're going to double 0, and it becomes 0. You guys see how easy this is? It's just remembering what a mapping means. 1 doubled is 2. Yeah, doubling. 2 doubled is 4. 3 doubled is 6. 4 doubled is 8. So remember that a mapping is the circle thing, because they're going to say, write this as a mapping. And if you on the test go, I don't know what a mapping is, you're right. You're going to miss easy points. All right, awesome. So like another way we can see a relation is a graph. So we can take our x, y points and put it on a graph if we want. We all know how to plot points. We start at 0, 0, and then we go over and up depending on where we need to be. We could also write an equation if we're asked to. So they could say, what's the equation that represents this ordered pair? And then you would have to do your best guess. Like I said, today we're not getting into really, really deep equations, really. Okay, so let me show you an example, okay? So I would just watch this. It's too easy. Like this is similar to what a homework problem would look like and a test problem. It says, write this mapping as a set of ordered pairs. So super easy. Instead of having the circle thing, they want it as an x, y point. So I'm going to abbreviate because I don't want to write the word Juan and Brown. It will take too long. So I'm going to do my x, y point. Now on the homework, they have you like type a little set thing. This is how they have you type it into the computer, but on the test, we don't really care. So Juan goes to Brown. Yes, there's a XY point. Then what's the next point? Ian, you got to help me out, people, or you're boring. Ian goes to Blue. And then continue, comma, Bailey goes to Brown, and then so on and so forth. We get the picture. Do I really need to do them all? No, you probably get the picture. So see how easy it is? It's saying take this mapping and write it in this format instead. Moving on. All right, now right here, just for fun, don't write it down, just curious, can you tell the pattern of this? So it's saying -3, becomes a 9. So negative 3 has something done to it and it becomes 9. How does negative 3 become 9? There's many ways, right? There's a couple ways, yeah? Let's look and see if there's a pattern. 3 also becomes 9. Apparently, 2.5 becomes 6.25. Negative 2/3, when it has the same calculation, becomes 4/9. Square root of 3 has some calculation happen and becomes 3. Can anyone figure out what calculation was happening in here? It's squared, yeah. Now, if you didn't get that, don't be so super worried. So it says, can you write the equation? So we can write y equals x squared, or we can write f of x equals x squared. We're really trying to go towards f of x instead of y, but it honestly doesn't matter. Aren't they the same thing? Yes? F of x and y are the same thing, right, everyone? You got to either talk to me so I know that you do or do not understand. Okay, cool. All right, look at this one. Once again, you don't need to write it down. You're going to get more out of practicing on the homework, so let's continue. This is too easy. It says, use this graph to create a mapping from the set of real numbers to the set of real numbers. So you would say to yourself on the test, I've memorized that mapping is the circle thing. So you would draw a circle, you would draw a circle. Let's put our x's in this circle. Let's put our y's in this circle. Here we go. I just go from left to right. Now, the annoying thing is they've done the worst grid ever. Let's look. What if this is 10? What are they going in? 2s? 2, 4, 6, 8, 10. I hate when they do that. Okay, so just keep in mind those are 2s. All right, so let's figure out where this first x value is. At what x value, if you had to guess? Do your best guess. Yeah, so because that was 2 and then halfway. So you said negative 3, yeah? And then what y value did it go to? This was 10, and then this would be 12, 14. I like it. Does everybody agree? Really easy. Then let's do the next point over. Isn't that at negative 2? It is at negative 1, or is it at negative 2? Oh, it's just the grid system. It's hard to see. You're right. It is negative 2, but it looks like negative 1 as well. And then that points to, we're guessing our best guess. 2, 4, 6. Okay, you're going to say 7? That's fine with me. You get the picture. Right here? Oh, you're saying negative 7. We have to just pay attention to our details. Good point, good point. Okay, then right here, next point would be negative. Negative 1 goes to 0. Now, do you guys get the picture here? Write out all the other points. We've done it. We're done. Okay. Any questions here? Okay, moving on. Now, look, listen. If you're ever asked to graph in here in 1010, they want you to do it the easiest, most basic way possible in 1010 for the most part until we get to more advanced stuff. But they want you to just graph by plotting points. So everybody, it says graph this relation by plotting points. So what you do is you create an XY chart and then you plug in any value you want. So I like to plug in values around the origin. Remember the origin is 0, 0. So and this is just me, you can pick different points. I like to plug in negative 2, negative 1, 0, 1, and 2. Isn't that usually what your teachers would pick if they're just doing basic graphs? We do about 5 points. Now be careful with order of operations. Last hour there were some people working on the homework and they were getting the wrong calculation and they just weren't plugging it in and being careful. So look, let's plug in negative 2 right there. That would look like this, wouldn't it? Negative of negative 2 plus 1. Yes? So just details matter here. So wouldn't that be 2 plus 1? Which is 3. Then we're plugging in negative 1. So that'd be negative of negative 1 plus 1, which is 2. Then we're plugging in 0. Negative 0 plus 1 is 1. Then we're plugging in a 1. So negative 1 plus 1 is 0. Plugging in 2. Negative 2 plus 1 is negative 1. We then go plot the points. Negative 2, down 1, 2, 3. We get the picture. Negative 1. I already forgot. I went to the wrong place. Let's refix this. Sorry, it's negative 2 up 1, 2, 3. Is it? Read me the points because I'm like, my hand's blocking it. Then what's the next point? Oh my heavens, negative 2 up 3. That's why I'm not multitasking. I am not a multitasker. You'll find that. Okay, then negative 1 up. Okay, 0 up. 1 up. Are we 2, negative 1? We're almost there. Okay, we've then got our points and we're connecting our points. Easy stuff. So don't overcomplicate it. What are your questions? Okay. All right, so let's remember what domain and range is. So you're going to be given a graph or a set of XY point or a mapping, and they're just going to say, what is the domain? What is the range? Recall, domain is what we're plugging into the function. It's our input. It's the cause. It's the source. Domain is considered an independent variable because you just start plugging stuff in. It doesn't matter what X you plug in. You're just plugging it in, and it has nothing to do with anything. So it's called an independent variable. So I would write that down. It's really not super important, but they could ask on the test, they could say, which is the independent variable? Which is the dependent variable? So domain, if we're looking at a graph, we're looking at left to right. Left and right is our domain. X values are left and right. Our range is the output. So we take some number, we plug it in. That was the domain. We calculate and we get an answer out. That's why it's called output. Range is the output of our function. It's the effect. It's the target. Range is considered our dependent variable because the answer you get out depends on what you plug in. You're not going to get any old Y value out. The Y value you get is dependent on what you plug in. So also, if we're looking at a graph, I like to say with range, we look up and down. And really, if I'm being more accurate, I should say our eyeballs for range should look from down to up. So I wouldn't overcomplicate it for the most part. I would just watch some of these examples because I think you're going to get more out of it than trying to write it down. So look at this first set of points. It says, state the domain and range of this relation. Remember, a relation can be many things. Right here, we have a set of XY points. So the domain is the X values. If you just have XY points, they just want you to write the domain with commas separating it. So look at the domain. What are the X values? Yeah, we could write, there's no 2. Our domain's X values. So we have -3. Then we have a 0. Then we have a 4. And then we have a -3. Now look, if I type in -3 again, it's not that I'm wrong, it's just you're writing unnecessary things. Isn't -3 already listed in the domain? So you wouldn't do that. It's going to mark you wrong on the homework. So we're going to think a little bit and say, you know what, that seems silly to write that again. We've already listed that in our domain. What's the range? Let's write it in order. Let's look at our Y values. What's the lowest Y value?
0.
Okay, 0. I don't think it would matter if you write it in order. I'm just doing it for fun. 0, 2, and 3. Okay, once again, we don't need to list 2 twice. What are your questions on that one with domain and range? Yes?
I'm going to ask the dumb question.
No, they're not ever dumb. I promise.
I'd rather know. Okay, so how did we're going to backtrack here.
Yeah.
How did you figure out what the domain was? I don't fully understand.
Okay, so we have to just remember from all our old math classes, domain is X values, always.
Okay.
It's left and right. So right here, we're not doing left and right because it's not a graph. We're not physically looking at a graph. So we're going to remember domain's X values.
Okay.
And then from previous math classes, range was Y values, yes?
Oh, okay, yes.
Great question. Okay, great question. All right, so once again, here's where it's a hoop jump, but you have to jump through the hoop. You have to do it. So I would write this down. They're going to ask you to write the domain and range 2 different ways. The first way is the way we've been doing it forever, the last few years of math. Interval notation is really what we use in upper division math. Interval notation is when we use parentheses and brackets, and we use the commas. Like, look below. That's interval notation. See, there's commas, parentheses, brackets. Remember that a parenthesis means not including, and a bracket means we're including that value. So not including, and bracket is including. Just a fun fact for you, infinity always gets a parenthesis, never a bracket, because infinity is not an actual number, it's actually a direction, it's a place. Numbers are only able to get brackets, and not all numbers get a bracket, it just depends on the problem. But my point is infinity has to have a parenthesis. If you try to put a bracket around infinity on the homework, it actually marks you wrong. Okay. Now, the other way we can write domain and range, the same answer, just a different way, is what's called, and this is new to you you did it back like when you were really young, but you didn't write it how UVU writes it. It's called set builder notation. Now, yes, if you get to the test and you have not studied what interval notation means and what set builder notation means, you're right, you're gonna miss points on the test because you didn't study properly. Because if you get to the test and they say, write this answer in set builder notation, and you go, oh crap, I don't know what set builder notation is, you're right, it's not that the math was hard, it's that you didn't study properly. So set builder notation, we have to jump, it's just inequalities. So I would write that in my notes. It is just inequalities. But UVU writes it all fancy. Now on the test, I won't really care too much if you write it exactly how they want it, but let's practice it for the homework. So what they do with set builder notation is they start out the answer with this little like this set. It's actually a set sign, kind of like a bracket in a way. So we're saying our answer is the set, and then for domain, isn't domain X values? Yes, everyone? So they're saying X is the variable. They list out the variable and they do this little like separation sign. In math, this separation sign is just verbally like X such that, which we don't care that it's such that. Just it's separating your answer now. And then we put our answer as an inequality. So inequalities are this. Do you guys know what I'm talking about? Greater than or less than or equal to. Or X is greater than or equal to. Or X is less than. That's when it's not including. Or X is greater than. Now, if it's negative infinity to infinity, they recommend just using the all real number symbol. It's just this fancy R. Whoa. So we'll practice this from start to end. This is making you feel stressed. You're stressing for no reason. We're going to see this from start to end in a minute. I'm just showing you, and then they close it with a bracket. It just takes some memorization of how they want to see it. So then for range, you do the little squiggly lines, and then you say, I'm using variable y. You draw the separation sign, and then you're doing the same thing. You're doing the inequality with y's. Y is less than or equal to. Y is greater than or equal to. Y is less than. Y is greater than. Whatever the answer is. Okay, so let's see an example from start to end. Do you guys need to take a picture of this? Right here? Does anyone feel like they'd rather have a picture than, did you get it written down? Yes. It means all real numbers so that you don't have to write negative infinity to infinity. It's kind of like a cheat way. It's hard to write negative infinity to infinity with an inequality. So they just recommend doing all real numbers, which means negative infinity to infinity. So look at this from start to end with me right here. It says, looking at this graph, what is the domain and range? And they want us to use both notations for practice. So let's do the first one. What is interval notation? What does that look like? Parentheses, brackets, yes? Okay, so domain is left and right. Where is this in general? Not x-intercepts, that is not what domain is. Domain is from left to right in general, overall, where's the graph going? Where's it going from left to right, my friends? Negative infinity to infinity. This is interval notation. Infinity always gets a parenthesis. The range is down to up. So what's the down to up? You're right, it's going down to negative infinity. Then it's going up to, what's the highest y value? 1/2. Let's see, is it 1/2? No, it's 1. Let's see, because you're right, this is 2. It's just annoying that when they split out the grid differently. So it appears that that's 1. Now here's where you have to be particular. Would you agree that 1 is included in the range? It's not an open circle, is it? It's not a dotted line. So is 1 included in the range? Yes. It is. So we need to do a bracket. Now listen, a lot of people will get it marked wrong because they will list out this in the wrong order. Remember, the smallest number has to be listed first. So a lot of people will accidentally go like this. They'll say the range is from 1 to negative infinity. 1 to negative infinity. Now, are they technically wrong? No, but they have it listed in the wrong order. The smallest number is always written first. Do you guys understand? Yes. So would it mark them wrong on the homework? Yes. Would I mark them wrong on the test? UVU actually does want me to mark off points for that. All right, let's do it the other way so that you can see and realize it's not stressful. It's just, once again, jumping through the hoop of understanding how to write it. So let's do domain as a set builder notation. So domain, we do this little squiggly set signs. We then say domain is the x values. We then draw our line, and then we write it as an inequality. So in this case, if you look at this, isn't the domain negative infinity to infinity? For inequalities, we just say all real numbers. So then mathematically, we write it like this. They say X, E just means encompasses, like is, all real numbers. Does it really matter if you use the E? No, but for the homework it might. You know what I mean? So just write, like, that just means is. The answer is all real numbers. Close your set sign. Let's do range. We're going to do the set for Y values such that, now let's see here. What are our Y values? They start at 1 and they go to negative infinity. So we have to write it as an inequality. So is it Y values, are our Y values greater than 1 or are Y values less than 1? Less than. We read inequalities from left to right, so write it properly. You're going to say Y is less than. See, it's not greater than. Some people confuse themselves because they go, well, this is greater than. Yeah, because you're reading it the wrong way. We always read inequalities from left to right. If you keep that rule in your head, you're not going to read it wrong. Okay, so let's read it. Y is less than 1. Now, should we do equal to? Should we add an equal to sign? It is including 1, so let's, details do matter here. And then we'll close our little bracket. Questions on that? This is how I'd want it written on the test. So pretty easy overall. Just takes some practice. And it takes some memorization. Yes, it takes memorization. I've never ever said to you that you won't have to memorize stuff in here because that's just not true. All right, let's look at this one. I would just pay really close attention to this one because I'm going to give you some tips and tricks. What is the domain? They want an interval and set builder notation. So here we go. You would say to yourself, the domain is the furthest left to the furthest right. Yes? So what's the furthest left X value? These are going in ones. Negative 1, 2, 3. So that would be negative 3. Now, actually, I did a parenthesis out of habit. Is it a parenthesis or a bracket? It's a bracket. So I've just got to pay attention to the details here. You're right. Bracket. Negative 3, 2. Looks like 9. And then do I do a bracket? My range is down to up. Furthest down to furthest up. Negative 5 up to. And then I better do brackets on those. Yes? Now let's do watch. I'm going to give you a trick for set builder notation when it's an inequality between two values. So I would just watch because I'm going to give you a trick. A lot of kids, when they see this, just don't type it in. They don't write it right. So we know for domain, we're saying this set for X such that. Now this inequality, they don't want you to write it out separately. They want you to write it as one flowing inequality. So let me show you a trick. What you're going to do is you're going to put your X like this. And then isn't X located between negative 3 to 9? Yes, everyone, negative 3 to 9. See, you put X in the middle and say it's located between negative 3 and 9. And then you always write your inequalities this way. Now I'll explain why in a minute, but just roll with it. We always put our inequalities this way on both pieces. So I put it this way and this way. Now the question is, should I put an including sign?
Yes.
Yes, right? Aren't we including, yeah? So then I'm going to put a line underneath. They always are facing in that direction. Now, I'll explain why, so that if you're like an advanced thinker, you're not just memorizing that. Let's look here. With inequalities listed like this, if it's an in-between value, you actually read it, instead of from left to right, you read it from inside out. So look, let's read this and make sure it makes sense. If we start from the inside and read it outward, how is it read? X is greater than, isn't it? If we read it from inside outwards, yes? X is greater than negative 3. Is that true? Yes. Does everybody see? You have to read it from inside out if it's in between. But then X is less than 9. See? X is less than 9. So it's just important that you understand that when it's an inequality with something in the in between two values, you read it from the inside out, not from left to right. Okay, so once again, we would close this. Now look, range. Let me tell you where some people are having issues with the homework. We do the set. They were using X again. What's the variable we generally use for the range? Yeah, so just use Y or it'll sadly mark you wrong on the homework. Y is such that, what's Y between? So use my trick. We're going to go Y. We're going to write negative 5. We're going to write 1. Inequality signs always face this direction. So they face in the less than direction. Equal to, less than, or equal to. Close your set. Awesome. Is that feeling pretty easy now that you've seen it and now that you see the hoop jumps that UVU wants you to jump through with notation? Okay, cool. Moving on. I don't think you need more practice with that, do you? With domain and range, the intervals. The good news is you will have practice on the homework, and then you can ask me for help if you need it. Moving on to same lesson, just once again continuing, but it makes them feel warm and fuzzy to call it 1.1.2. So now we're just dealing with functions in general. Like for example, well, let me say, sorry. They're going to ask you to determine like what is a function, is it one-to-one? And then once again, they're going to ask you to find domain and range and inverse. So it's just reviewing old stuff. So let me tell you something, everyone. For something to get this name, the special name function, it has to have a particular feature. Now, it's not bad to not be a function. For example, it's just a title. Like if I'm Sterling Scholar and you're not Sterling Scholar, it doesn't mean you're like bad, less than me. You just don't get the title Sterling Scholar. That's how functions are. So functions only get the title, quote, function, if each input has exactly and only one output. So I'm going to say that a little easier. For something to get the special name, quote, function, each x value can have only exactly one y value. So let me show you when this is an issue, okay? So when it's not a function, not a bad thing, it's just not a function. If I have the point 2, 1 on a graph, and I also have 2, 3, do you see how that x actually has 2 locations for y?
Yes.
See, look, let me show you. 2 is pointing to 1, 2 is pointing to 3. This would just not get the special name function. It's not bad, it just doesn't get the special name function. All right, so let's look at this one right here. It says, is this a function? Does it get special name, quote, function?
Yes.
These are our x's, these are our y's. We know that because it's pointing in that direction. So this is our input, this is our output. Each of those x's only go to one location for y. Do you guys agree? Yes. So yes, it gets the special name function. That takes memorization. That's not hard math. That takes memorization. That each x can only point to one y. Okay, let's look at this one. Now look, think for a minute before you answer. Remember, for it to get the special name function, each x can only point to one y value. So look at this for a second before you answer, just to see. Is this going to get the special name function? Yeah, it is. And last hour, a lot of people said no, and it makes sense of why they said no. It's a very common mistake. So look at these x's. Each of these x's are only pointing to exactly one location. Do you guys agree? So it does get the special name function. What was throwing people off was if we were to look backwards, isn't negative 14 pointing to 2 things, everyone? But that's not what you do to figure out a function. It's the other way. Your x's can only point to one place. So then, when we talked about that, it actually brought up a word that comes up later. Let's just get her done now. The word one-to-one. Write it in your notes. One-to-one is the opposite of, quote, function. Now it is the backwards process. Each y value can only have one x value. So our y's can also only point to one location for it to be considered a one-to-one function. So that takes memorization on your end for the test. What does one-to-one mean? Our y's can only point to one x. So this one is a function, yes, but it is not considered one-to-one due to this location here and due to this location here. Do you guys see how those are pointing in 2 places? So it is not one-to-one. Let's look back at this example. On the test, did they say, is this a function? You said yes. If they say, is it 1-to-1? You'd say, yeah, look at the y's. They only point to one x. So you'd say, yes. Wow, it always changes to eraser on accident. Is there anyone confused? That can be confusing. You have to really, once again, check your brain before you answer those. Even I do. Okay, let's look at this one. Is it a, quote, function? So the answer is no, due to this location, right, everyone? It's pointing to 2 places. That x has 2 y values. Okay, is it 1-to-1? So some people say yes, some people say no. People who are saying no, why are you saying no? Yep, 7 is pointing to 2 places. Do you guys see? So it is also no on the 1-to-1 scale. Name. I don't know why I used the word scale. It just felt good. All right. I think we get the
Like,
pic.
it can be a one-to-one. Like it can't be a one-to-one if it's not a function.
No, that's not true. They actually don't have to go together. Something can be a function and not 1-to-1, and something can be 1-to-1 and not a function. And something can be not a function. Oh, wait, is that true? I see. Are you saying, say that again?
Was like.
Let's think advancedly. Let's think back. Okay, so what are you saying?
On that one, they're both wrong. But like on the previous one,
Uh-huh.
it's like it's a function, but it's not a one-to-one. Like
Uh-huh.
a one-to-one can't exist without it being a function. Does that make sense?
So maybe, so you're saying a 1-to-1 will always be no. I'm just trying to reword it so my brain can comprehend it. So you're saying a 1-to-1 will always be no. It'll not be 1-to-1 if,
A function is not present.
yes. You're an advanced thinker. Yes, that's good. They actually talk about that later. So we should bring that up again. And then hopefully people won't be quite as confused. But you're thinking really advancedly. That just took me a minute. Okay, awesome. Look at number 1 here. It says determine if the relations are functions, not if they're 1-to-1, if they're functions. So what are we checking for? Each x only points to one y value. Yes, we have to memorize that. So let's look. Do all of those x's only go to one direction? 0 goes to 6, 1 goes to 7, 2 goes to 9, 4 goes to 6. Is that a yes? It's a function. There's x isn't listed twice. That's honestly the easy way to do it. If x is listed twice, the x is pointing to 2 places. So yes, it's considered a function. How about this next one, number 2?
Yes.
Also yes, -6, 7, -8, 5. X isn't listed twice. How about the next one?
No.
-8 is listed twice. So if we were to draw the visual aid, our -8 would go to 4 and our -8 would go to 6, which means it is not a function. Good. So we already talked about 1-to-1. So we're good. Okay, let's move on to inverses. Everybody, let's write down the word inverse in our notes. So inverses are really easy. So to find an inverse of a set of xy points, it's simple. You just switch your xy points. You literally switch x and y. So for example, it says state the inverse function of 2, 1, 3, 4, 4, 7, 5, 9. So in the homework, we'd have to just type it in correctly. We do our little set sign. We would then say 1, 2 is the inverse point of 2, 1. 4, 3 is the inverse, whoa, I almost did a squiggly, parenthesis, is the inverse point of 3, 4. 7, 4, 9, 5. Did I mess that up at all? We just switch our x, y points. So memorize that. What are your questions on that? Okay. So think about this. If you're switching x, y points, aren't you literally switching the domain and range? Aren't x values domain? So if you say now that's the y value, wouldn't that be the range of the inverse, everybody? Your domain and range are literally switching. Think about it one more time. I need more head shaking that you see what I'm saying. If I tell you, here's x, y points, find the inverse. Aren't you literally switching your x, y points? So doesn't your domain become your range? Your range become your domain, yes? Okay, it makes sense. We're just switching x, y points. Okay, so then right here, it does make note of this. This is actually the first year they really actually in 1010 gotten into this. I would make note of that. For a function to have an inverse, so this year they're going to put some on there that do not have an inverse. So for something to actually have an inverse, the original function has to be 1-to-1. And that's kind of what she was talking about over here, right? So once again, for a function to have an inverse that exists, the original function has to be 1-to-1. So what we would check first is, what does the word 1-to-1 mean? The y values only go to 1x value. And if that's true, then we can switch our x, y points. If we check and the y value goes to 2x's, we're not supposed to switch our x, y points. We're supposed to say no inverse. So looking at these next examples here. I'm going to zoom in if you don't mind. Right here it says, find the inverse if it exists. So you would have to have memorized for the test. I need to check to make sure it's 1 to 1. Check and make sure that your y values only go to 1x, which means if you have a y value listed twice, it is not 1 to 1. Is that true? So look at the y values here. We have a 6, a 5, a 4, a 3, a 2. Is it ever listed twice? No. So we're good. So finding the inverse is easy. We go 2, 1, 3, 2, 4, 3, 5, 4, and 6, 5. And then if we're being technical, we put our little set sign. How about the next one? 3 is listed twice. 2 is listed twice. So you would say no inverse. Okay, good stuff. All right, let's read this. It says, okay, this is a really good question. I could totally see them putting one like this on the test, and it's super easy. Don't overcomplicate it. So it says, if a one-to-one function has this domain, the original function has this domain, and a range of -infinity to 6. It says, state the domain and the range of the inverse. That's super easy. What do? Just switch them. The domain must be of the inverse -infinity to 6. True, everyone. And then the range must be -infinity to infinity. We just switch our domain and range. Awesome. We're doing really good. We're close to being done here. Okay. Look at how to find the inverse of an equation. We saw how to find an inverse of an xy point or xy points. Now let's do it with equations. So you've done this before in previous math classes. Let's review it. To find the inverse of an equation, we do the same thing. We switch x and y, just like we did with our points. We just have an extra step. So like right here, my first example. Right now we have y equals x plus 5. We switch x and y. So such x equals y plus 5. And now we find the final answer, which, think about it, functions, we usually generally like to write them as y equals. True? So let's get it to be, right now it's not y equals, it's x equals. Let's fix it. Get it to be y equals using algebra. So get piece by piece, get y by itself. What would we do? -5. So now we have x minus 5 equals y. Boom. There's our inverse. True. Easy stuff. All right. Same thing here. Switch x and y. X equals y squared. And then once again, you say to yourself, we like to write functions as y equals. So let's get y by itself. Use algebra to get y by itself. Square root. Now here's what you have to remember. If you are solving, and aren't we solving for y? If you're solving and you mathematically take a square root, you actually have to put a plus and minus. You learned that in previous years. You have to put a plus and minus. So I'm going to say that again. If you're ever solving and at any point you take a square root, at that point you put a plus and a minus. So we have plus and minus the square root of x equals the root and power are undoing each other equals y, and we're done. Because y is by itself. Okay, right here, let's do this next one. Find the inverse. We switch x and y. Solve for y. What will we do? You got to go in the correct order. What would be the first step? Times by 5. So we have 5x equals y minus 7. Okay, next step to get y by itself. Add 7. So then we have 5x plus 7 equals y. Boom, there's our inverse. All right, last example of this type. Find the inverse. So we switch x and y. And what would be the very first step to get y by itself? Yeah, we got to undo the square root with a square. Squares don't get plus and minuses. That's not what I said. Didn't I say when taking a square root? Did we just take a square root? No, we took a square. Okay, no plus and minus necessary. So we have x squared equals, the square root and square cancel out or whatever, y minus 3. So then from here, get y by itself, so we'll add 3. So we have x squared plus 3 equals y. Boom, there it is. That's our inverse. Pretty easy stuff. Wouldn't you agree?
Yes, ma'am.
Awesome. All right. Now, don't overcomplicate this. Let's just read this, just so that if we get to one like this on the test, you'll realize this is one of the easiest problems you're going to see. It says, it just wants you to see if you can write an equation. So read it with me. Sometimes people overcomplicate it. It says, if f is a function that says add 3 to any real number, then write the equation. Let's write an equation for it. What would that be? It says add 3 to any real number. So we say f of x is equal to, what's the equation? Yeah, 3 plus x. X plus 3. It doesn't matter what you say. X plus 3 is the same thing as 3 plus x. Isn't that the equation, everyone? All right, now look at part A. It says create a mapping using at least 4 numbers and a variable that describes the function. So we know mapping means the circle thing. We then put x and y just to give ourselves a good visual. So now we know that we need to plug in 4 numbers. I'll just do 1, 2, 3, 4. Anyone mad about that? And what are we plugging it into? This, which right here, I'm going to write it up here for myself so I don't forget. Isn't it x plus 3 that we're plugging into? All right, so we're going to get 1 points to, plug in 1, we get 4. 2 points to 5, 6, 7, and then it says, and a variable. So isn't it that we start with x, we plug it in, and the calculation is x plus 3? Aren't we adding 3 to our x to get our y value? Isn't that how we got that? So that's why I'm putting that there. X plus 3 is how we got 4, 5, 6, 7. All right, that would be how you write it. Now look at the next one. It says create a mapping that describes the inverse. So what I would do is first find the equation of the inverse. So I go back to my original equation and I switch x and y. This is just me. And then I solve for y. So 1i minus 3. So I have x minus 3 equals my inverse. That's my equation. So now I'm going to do the mapping. I do my circle thing. I put x here. I put y here. Then I just write myself a note. We're doing x minus 3. I plug in values. 1, 2, 3, 4. If I plug in 1 into x minus 3, don't I get negative 2? Plug in 2, I get negative 1. Plug in 3, I get 0. Plug in 4, I get 1. And then it says, and a variable. So I'm starting with x, and I'm plugging in and calculating using x minus 3 to get the y value. So it's just understanding how they want you to write it. All right, I think we get the picture here. So don't overcomplicate it. Like, look at these. It says, once again, write a function f. When applied to any domain element, x adds 4 to the domain element. When I first read that, I was like, what? And I'm like, okay, I'm not going to overcomplicate this. It just wants me to write an equation that is what it's saying to do. What is it saying to do? X adds 4. Yes, everyone. So don't overcomplicate it. So you're going to say, they actually want you to use f. So you're going to say f of x is equal to x plus 4. All the other stuff is just using fancy language. Okay, let's look at the next one. G, so we're going to do g of x equals, and then it says, when applied to any domain element, x multiplies by 7. So what would that be? 7x, or x times 7, right? Same thing, everyone? And then moving on to the next one, it says function c. So we're using c of x equals, it says t, the element t squares. How do we write that? Yeah, t squared. So this is really easy stuff. It's just understanding how to write it. H of x, when applied to any domain element z, multiplies the domain by negative 3 and adds 8 to it. So we're going to use, I used x, but actually what did they say they want you to use? Z, but it really doesn't matter. On a test, I would not mark you for getting the wrong variable. A variable is a variable. Negative 3 times z, and then plus 8. Awesome. So don't overcomplicate it just because they use fancy language. All right, this is the last thing they want you to know. How do you know if something is a function if it's a graph? So everybody, it's called the vertical line test. These are tricks to quickly doing this. If you're given a graph and they're asking you if it's a function, you check by drawing vertical lines. So what you do is you draw vertical lines, and if it only ever hits your pencil one time, it is a function. Now, if you're drawing a vertical line and it hits it in 2 places, now think about why that's not a function. At that x, it's now hit in 2 places. Do you guys see that would be 2 y values? So that's why the vertical line test works. If they ask you if it's 1-to-1, 1-to-1, we use the horizontal line test. So we sit and draw horizontal lines, and if it only ever hits your pencil once, it's 1-to-1. So let's say we're drawing horizontal lines and it hits twice right there. Now we know it's not 1-to-1. Because that means at that y value, it is hitting 2 x values. So let's look at this picture here. So remember, function is the vertical line test. 1-to-1 is the horizontal line test. So look at this graph right here. Is it considered a function? Let's draw vertical lines. Does it ever hit my pencil more than once? Just once. Look, once right there, 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 once right there. Yes, everybody? So is it a function? Yes. Is it 1-to-1? We draw horizontal lines. We're good, we're good, we're good, we're not good. It hit 1, 2, 3 times. Do you guys see? So is it considered 1-to-1? No. Okay, now look, they also want to make sure that you just know how functions calculate. So look, given a graph, these are inputs and outputs. These are x, y values, are they not? The whole thing is x, y values connected. So look at what this says right here. It says, what is f at 0? Remember, we write this as f of x. So what is 0? X. Do you guys see? X is 0. So what you do is you go to the location of x equals 0. So remember, x are these values. So if I go to x equals 0, isn't that right here? What's the location of the graph at? What's our answer? Out. 0, comma what? We'll just call it 1. How about to make our lives easier? Yeah? 1, like in grids of 1. So isn't it up at? Is it? Sorry, my thing was blocking it. So over 0 up 2. So the answer at f of 0 equals 2. So right here, this is f of x equals, that means x is 6. So I go over 1, 2, 3, 4, 5, 6. I'm right here. What's the output? 1. Yes, everyone. Now look, though, be careful. This is not the same thing. This is not f of some value. Look, it says f of x equals 0. This is backwards. Why? What does f of x really mean? Y. This literally says y equals 0. So now we're actually going to go to the y equals 0 and state the x value. So I'm erasing. Now this took a minute even last hour for my brain to like hit it right. So I'm like, okay, I have to remember, ranges down to up. We're going to the height of 0 from down to up. True, everyone? So if I'm going from down to up, the height of 0 is right there. Do you guys agree? That's the height of 0. So what is the x value at? -1, 2, 3. You're right. It's -3 would be our answer there. Do you guys see? I was just asking the backwards process. This says y equals -1. So I have to really look my brain and go, okay, along the graph, where is -1 from down to up? Isn't it right there? Isn't that -1 from down to up, everyone? So then you say, what x value is that? I've got to count. 1, 2, 3, 4. -4 would be our answer. All right, you get the picture here. Look, are these right here? Let's just do these. Is this a function? Yes. Is it 1-to-1? No. Is this a function? Is it 1-to-1? Is this a function? Is it 1-to-1? Okay, good stuff, good stuff. I think you get the picture. Go do the homework. So get on Canvas, start on the homework. If you have not got registered yet for my class, you need to do that right now so you don't miss the deadline.
I went to go get to the meeting and there were like 6 people there and she's like, I don't